Assalamu alaikum warahmatullahi wabarakatuh. Today we're going to continue doing chemistry Regent for 2019 January. We are now in part C. Part C. Answer all equations in this part. Direction from 66 to 85. Record your answer in the space provided in your answer booklet. Okay. So, in a laboratory investigation, a student given a sample that's a mixture of 3 grams of sodium chloride and 4 grams of sand, which is mostly silicon dioxide. The purpose of investigation is to separate and recover the compounds in the sample. In the first step, the students place the sample in a 250 milliliter flask. Then, 50 grams of distillated water are added to the flask, and the contents are thoroughly stirred. The mixture in the flask is then filtered using the equipment represented by the diagram below. So, explain the terms of the solubility. Why the mixture of the flask remain heterogeneous even after through stirring. So in that part, according to the term of so it's heterogeneous because it's two separate materials and I can't identify both of them. Because sodium chloride is soluble in water, while sand isn't soluble in water. So one of them is soluble, the other one is insoluble, and I can identify the materials. Based on table G, said the evidence that all sodium chloride in the flask would dissolve in distilled water at 20 celsius. So I go for the reference sheet, table G, sodium chloride. Where is the sodium chloride? Sodium chloride. Here is the sodium chloride. At 20 Celsius degree, it can dissolve almost like 38, 36 gram per 100 gram. Now, for the 50 gram, so now here, it can dissolve 36 almost for 100. So for the 50 milli we use, it should dissolve 18, but the sample has 3 grams. So for sure it's going to be soluble. For sure it's going to be soluble. Now, describe the procedure to remove the water from the mixture that passes through the filter and collect in the beaker. So I'm going to evaporate or boil the water. So I'm going to add energy. One of the students said that 3.4 grams of sodium chloride were covered. Now he asking you about the percent of error. So I'm going all the way for the last page and finding the percentage of error. Here it's the measured value, which is 3.4. The actual one, we know it's 3 over the actual multiplying by 100. So this is the setup. I used percent of error formula. Question number 73 through 73, we have a diagram showing us the volume of helium versus the temperature at 100 kilopascal. Now, determine the temperature of helium at a volume of 15. So, what I'm going for the volume 15, okay, here, and it's intersecting here. So now I'm going all the way down. So this one goes by 10, so means here it's 33, and that's 340. So means the value should be around almost 336. So that's the temperature. Okay. Now, the second part asks, explain the term of particle volume. Why the sample of the helium can't be compressed by piston to zero volume? Because the particles has a volume. The particles of the helium has volume. State what happens to the average distance between the helium atoms as the gas is heated. Gas is heating, so increase the temperature, increase the kinetic energy, and increase the kinetic energy, increasing the distance, because now the particles are going to move apart from each other. Now, state the change in pressure that will cause the helium in the cylinder to behave more like the ideal gas. For the pressure, it should be less pressure. And if he asks you about the temperature, so increasing the temperature. So increasing temperature and decreasing pressure leads to gases behave like ideal gases. Okay. Question number 74 to 76. 74 to 76. Now he gives us a balanced equation. Okay, balanced equation. And he's saying that the balanced equation below represents the reaction between 5-gram sample of zinc metal and 0.5 molar solution of hydrochloric acid. The reaction takes place in the open test tube at 296 Kelvin and 1 atmosphere in laboratory activity. Now, step one change in the reaction other than adding catalyst will increasing the reaction. Increasing the reaction is going to be through either increasing the surface area. So instead of having a bulky zinc, I have to crush it and increasing the surface area. Second, increasing the temperature. Increasing the temperature is going to increase the collision by increasing the kinetic energy for the molecules. Okay. Now, draw a potential energy diagram. Now, if you observe that's going to yield energy, means it's exothermic. So what does it mean? The energy for the product is less than the energy for the reactant. So it's going to be like that. So that's going to be the activation energy. And this is energy of reactant. And that's energy of product. Okay. Explain why the reaction will not reach equilibrium. So if you observe now what he said in open test tube. And if you look for the products, we have gas. So what does it mean? The hydrogen is going to skip the test tube. It's going to push all the reaction to go to the right side to compensate the deficiency of the hydrogen. That's why it will not reach the equilibrium, because it's open test tube. Question number 77 through 79. Now, this is talking about crude oil primary mixture. Now, the question number 77 determine the number of carbon atoms, alkane, and 22 hydrogen. So I go for the reference sheet, and I'm going to get the formula for alkane. Formula for alkane is CN H2n plus 2. Now the hydrogen is 2n plus 2. The hydrogen number is 22, so equal to 2n plus 2. Subtract 2, so 2n equal to 20. Divided by 2, so the n equal 10. So the number of the carbon must be 10. The number of the carbon must be 10. Now, set the temperature range for the fraction collected that has octane. So now we have the term octane. If you don't know what is octane, I go for the reference sheet. Okay, octane means 8 carbon. So I have C8. I go again. Now which one has carbon 8 here? So the average temperature should be between 40 to 200. Now, draw the structure formula for 3-ethyl hexane. Hex means 6, N means old single, and 3 means position 3, and ethyl is the substitution. So at position 3, I have ethyl group, which is C2. Now I'm doing C, 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 C. So 1, 2, 3, 4, 5, 6. Okay, now the substitution on number 3, I have ethyl group, which is C. Now I can do the hydrogen. So here is hydrogen, 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 hydrogen. Question number 80 to 82. Now in a laboratory activity, students titrate 20 milliliter of sample of hydrochloric acid using 0.025 molar solution of sodium hydroxide. In one of the titration trials, 17.6 milliliters of the base solution exactly neutralize the acid sample. Now, the question: identify the positive ion in hydrochloric acid. So, as we know, the acid means proton donor. So, the positive ion is going to be the hydrogen ion. Also, the hydrogen ion is going to be soluble in water, giving me hydronium ion. Both of them is correct. So if I write hydrogen ion or hydronium ion, both of them is correct. Now, show numerical setup to calculate. So if you're looking for the last page and go all the way down the titration part, saying I'm going to use that formula. So M acid volume acid equal to M base volume base. Okay, so that's a formula. Now I'm going to set it up. So the volume for the acid is 20. So 20 molar of the acid equal to the volume of the base 17.6, and the molarity is 0.025. To find the molarity or the concentration for the acid, I multiply 17.6 by 0.0025 and divide by 20. That's the numerical setup. For question number 82, the concentration for the base. So where is the base? And here is the concentration. 0.025. When I have a decimal, I count from the first significant number from the left. So 0 isn't significant. This 0 isn't significant. So that's the first significant. I start to count 1, 2, so it's two significant number. It's two significant number. Now, the concentration, okay, we're done with this part. The last part. Now, in the past, some paints that glow in the dark. So now we have an introduction at giving me radioisotope. And now, explain in terms of half-life why RA 226 may have been used more often than the other isotopes. So here, isotopes means I have to look for the decay and the T-half. So when I look for the half-life, that's 2.6, that's 1522. So that's the greatest T-half, means it take 1599 years to have the amount of it. Okay, so that's why. Complete the nuclear equation. So I'm going for the nuclear equation in the booklet. Uh, in the booklet here. So if you're looking, give me a second. Okay. If you're looking, so before, so the sum here should be 61. So 61, what's the number adding to -1 giving me 61? That's 62. Now the top should be 147. So what's plus 0? 147. Now I know that the element has 62. So I look for the reference sheet for which element has 62. Okay, so here 57, 72. So it's all the way down. 62 is SM. So that's SM 62, 60. 2. Now, what is a fraction of the origin after 17.4 years? So the decay is 5.8. So the number of T halves equal to the given amount divided by the T half, which is 5.8, equal to 3. So I have 3 T halves. Means I have 1, 2, 3 R. So if I start by 1, half of the 1 is half of the half is 1/4. So 1/8. So it's end by 1/8, or I can't write 0.125, or I can write 12.5%. All of them are applicable. Okay, so now this is the end of this part. This is the end of that region. Hope you understood, and have a good day. Assalamu alaikum wa rahmatullahi wa barakatuh.